What I'd first like to do, obviously, is introduce myself. I'm Pete Bowen, for those of you who don't know me. I'm the CTO here at Carbon Z, and I work across the entire sort of technology stack. So that's architecture, IT, power, cooling, and all the other services that go around that, and augment the team that are already here. What I'd firstly like to say is a big thank you for everybody's attendance today. I hope you found it really interesting. And if you've got questions or queries, then contact one of the team and they'll be able to answer your questions. And the second thing is I'd like to thank all the speakers and our partners in the room. Excellent job, guys. I think that the point of today was to sort of outline our sort of end-to-end service delivery and the technologies that we are deploying and will deploy across the UK as we go forward, which gives us a sort of platform or the infrastructure. Can't they turn these up? I've got a sore throat. The purpose of today was to outline our end-to-end service delivery, our infrastructure, what our capabilities are, how we're going to expand on our roadmap into the future. So that sort of gives you the hardware level and the sort of strategic level. But to actually use that, you have to have a workload. And now, most companies have existing workloads. They run on existing platforms, and they need to be able to migrate into the new world, really. So what I'm going to do is to sort of outline how you can do that. So how we get the best out of liquid cooling, what's the best approach? So you've seen Immersion, and I hope you're impressed with it. We think it's the way forward. Directed chip has a place for sure, and hybrid air or a mix or any of the above. But you actually need a different approach to designing IT platforms as you move forward. So it's a different world in that arena also. But let's look at the benefits in terms of cost. So data center operator benefits, so that would apply to us, but indirectly that actually passes on to our client base. So lower infrastructure capital cost, we can minimize air handling. We have a greatly reduced footprint, as has been already said today. You can build out those environments far quicker because we have a known design model, and obviously it's far more sustainable. That then gives you lower operating costs and lower hosting costs for our clients and their clients. So what would you put in a liquid cooling environment, whether it be immersion or direct chip? Well, you can actually use like-for-like spec, which people don't sort of, they don't have that or advocate that as a use case. They want to use high density compute or AI or GPUs, but you can actually gain benefits from like-for-like. So if you've got a Dell R650 that is in air, you can just strip the fans. This does work. He lied to me. You can basically make it native for immersion, and you will actually gain in terms of power, costs. It's more sustainable. You get a longer life cycle for that equipment, so your capex life cycle is longer, if you like. So you are effectively reducing your overall operational capital costs in like-for-like in immersion. Although not the best, it is possible. So high density compute, very, very similar, obviously, but you can get far more performance from high density compute in immersion. So you get far higher CPU density. You can run higher loads than you can in air. And air cooling struggles here, which you've probably got that message from today anyway. And then obviously you've got hyper-converged environments. So imagine now you've got compute, network and storage all in immersion. Some of that is not possible at the moment, but a lot of it is, and it's coming. Networking equipment, for instance, is being developed for immersion. So you can actually provide yourself a data center in a box, effectively. And if you seal that box, you can deploy it anywhere, even on the roof of a building. Now imagine you have a dozen of those boxes on a dozen roofs somewhere. You've now got yourself a virtualized environment connected via dark fiber with no single point of failure, because you architect your IT platform to cater for multi-site architecture. So, that is the idea of the atom, effectively, but we can go smaller. Tony mentioned protons earlier. Well, basically that is a bath or an immersion environment that can sit on a roof, completely IP66, 67 sealed, runs autonomously, deployed very quickly. So GPU-based stuff is a little bit different. That's generally for AI, deep learning, machine learning, rendering, that type of thing. Some GPUs are not best in immersion, so they use direct to chip. But there are immersion capable GPUs. So again, as sort of Steve outlined earlier, there are use cases for each. But DTC has its disadvantages. It's very complicated, very expensive, and when you want to scale up, it's very disruptive. So basically, how do you migrate into an immersion type or liquid type environment? Basically, you have to go back to the drawing board to a degree. A lot of modern platforms are virtualized platforms, but you need to know what you have. You need to know what's going end of life. You need to know where you need to be so you can plan for a migration path. Now that may be services, that may be hardware, or a mixture of both. And then you need to plan out your transition in waves of your workload migration, and then implement it. So I've done a couple of these projects, and you can be talking anywhere from 9 months to 4 years to actually deploy fully, a transformation transition project. But for immersion to work in the industry, that has to happen. Air is going out of fashion far quicker than people would imagine, actually. So how do you achieve that? Well, traditionally, data center colo buyers and data center buyers and operators are disjointed from their enterprise and technology architects in the same business. So traditionally, somebody will go out and buy colo space and then expect the IT teams to go and throw a bunch of servers into a rack and job done. It doesn't work that way in immersion, because you need specialist environments, you need specialist teams to operate it. You need the solution architects and enterprise architects to engage with the colo buyers, so you know that the environment is suitable for that architecture. So that's a step change, really, in the way deployment of immersion capable environments are deployed. If you've got a greenfield project, obviously it's a different story, because you can highlight an immersion environment, and then you can design for that environment day one. And effectively, you don't have the migration and transition and transformation to go through. You can just design for that environment day one. So deployment considerations, giving a sort of mixed hybrid environment, we take the view that effectively your data centers need to be smaller. You don't put all your eggs in 100 megawatt basket. So our sort of intent is to deploy smaller, agile, closely located data center environments, which are hybrid and designed for that ICT platform. So effectively, you can have a multi-site data center cluster that has no single point of failure in it, because you've designed for failure. So if you lose a site, the other site's already taken over those services. And the other thing, of course, with the Atom is that's highly scalable, because you can have 100 or 1,000 atoms as opposed to 5 to 10 200 megawatt data centers. But typically what you'll have is also a hybrid environment. So based on cost, deployment, operational considerations, you'll be looking at on-prem, cloud, and colo, and that's the model I've seen, and I'm pretty sure some of you have seen that model as well coming to the fore. A lot of companies who are in the cloud now, they're extracting themselves because it's far too expensive. And cloud providers don't currently provide immersion capabilities at scale. They're still using legacy environments. So basically it's horses for courses. So companies need to go back, look at their IT platforms, what they're delivering now, where the savings can be made, what to transform and migrate, and then put a plan in place to actually do that. So what are the high-level benefits here? So in Immersion, obviously, ahead of the curve across industry, really. Much lower costs. If you've got an ephemeral architecture, you have no downtime. Build it where you need it. The edge case, I've yet to find a person who can define what an edge data center is, because everybody has their own view on it. But effectively, it's putting that environment close to your customer base, effectively. You can reduce capital costs. You have a higher sustainability profile and a much lower carbon footprint. And you've got deployment agility. You don't have to wait 5 years for a data center to be built. You don't have to wait 5 years for it to be powered. You don't have all the planning issues. You can basically put that environment in small environments, small locations with power already, and then mesh that together, and effectively you've got yourself a virtual data center which can span the UK, you can span Europe and further afield. And it's a known environment, that's the other thing. You don't have to design for each environment. Baths have a standard profile, you know what it is. It says what it does on the tin, you know how big it is, and you know how to operate it. So again, that reduces the deployment timelines, and it's highly sustainable. This is the one that really sort of is it's obvious. Change is inevitable. In 5 years' time, liquid cooling will be the way forward. It'll be the de facto standard. So people need to be looking at how they transform and transition to that environment now. Because I've been on projects where it takes 2.5 years just to plan a project, which is going to take another 3 years. So that's why immersion isn't ubiquitous at the moment, is because people don't understand necessarily what its advantages are. They don't know how to operate it, particularly widely across the industry. And there's a lot of work to do to make sure that you've got the cost profile right, the technical profile right, and then the deployment profile right. And that's all from me, really. Quick summary. We're actually having a Q&A session later on after a tea break. But if you've got any questions now, please fire away. Yeah?
You're saying about rapid deployment of data centers.
Yep.
Okay. Now, I know how fast I can deliver you a data center.
Yep.
How fast would you like me to publicly say I can deliver a data center?
Are you going to be realistic, Tony? That's the thing. Depends.
Depends. But take a half megawatt as a reasonable footprint. The 76 square meter atom.
6 months.
6 months?
Yep. And connected.
5 days connection over there. I'll go to Richard. Yeah.
Depends on the location, and it depends on fibre capability, etc. But our partners can sort that out fairly quickly. So it's really down to planning, what power is available, does it need an uplift, what's the architecture of the building. We've already got a known design. We just change that design slightly, to fit into that location. So it could be 3 months, but that's optimistic. I think 9 months as a max, but average 6 months.
Yeah. Okay,
Fully immersion or, hybrid here. The other thing to just be aware of, as I mentioned earlier, is a lot of network kit is not immersion capable at the moment. So you do need an air environment alongside your immersion capability, particularly for the high-end firewalls and large switches, etc., because they do get rather hot. But bearing that in mind, hybrid in-row air cooling is very efficient, the latest technology, and you wouldn't need a great deal of it. So we've designed our atoms to actually cater for that. So you'll notice on the drawing or the graphic earlier, there is an in-row rack footprint in there, particularly for that, and also for storage. A lot of people say you can't run hard drives in immersion. I think that's a myth. You can, because they're gas sealed, so they're not going to have any liquid affecting that. The problem there is the weight, floor weight. So if you fill the bath that's around the corner with hard drives, it gets really rather heavy. So it's all about structural loading there. But obviously all of that's done in the sort of pre-planning stage for locations. So it's not really an issue. It's basically designing courses for courses. What is that location capable of? What are its design constraints? And how can we get that into a workable deployed environment? Any other questions? No? Okay. Well, that's a summary then. Are we having tea now, guys?
We're actually setting up for tea now. We are running massively ahead of schedule, so we're going to hold you here till 4 o'clock anyway, so you better get your questions ready to hammer the guys, yeah? So, yeah, if we'll take a break now. We'll keep it going through till 25 past-ish, half past-ish, see how it goes. So please grab tea. The guys are just setting it up. Please bear with. Okay? Thank you, Pete.
Walking round the room singing stormy